Good day all, and thanks for tuning in. I'm Kaya Guten, BD at Pitch Talk, and I'm absolutely thrilled to kick off the Zero-Knowledge DemoDay. Today, we will bring 8 ZK startups on stage, each precisely granted 5 minutes to pitch their vision and potential while showcasing a demo. In addition, after each showcase, we will move on to another 5 minutes of a burning Q&A round featuring our panel of judges. Last but not least, I'm very excited to share that we have 8 ZK luminaries and top voices on board that will join us on the stage for a captivating panel discussion centered around the topic, the state and potential of ZK proofs. So please stay tuned, as today you will obtain a little glimpse into a trustless future. So before we move on to the very first showcase, I would love to highlight our agenda and the participants. Here's our agenda of today, our showcasing stars, our amazing speakers for our panel discussion, and not to forget, our judges and media partners of today. Many thanks for joining us. We're about to kick off the very first showcase, and we'll start with ZK Link. So please, Neil, get ready as I'm about to bring you on the stage. Hey, welcome back.
Hello, everyone. How are you? How are you, Okaya? It's good to be back.
Yeah, I'm doing very well. I'm very excited to have you on board again. So with that said, let's start your showcase. I will bring now your slide on the stage and you may kickstart your pitch.
All right, cool. Okay, hello, everyone. My name is Neil. I am the PR lead for ZK Link. At ZK Link, we envision a future of 1,000 blockchains and rollups aggregated. Our mission here is to unify a aggregated liquidity and unified interoperable blockchain ecosystem and experience for all. The main problem statement that we're trying to solve here is, with the growth of layer 2 solutions, there has been an increase in liquidity fragmentation across rollups. Liquidity is siloed, and doing cross-chain transactions on different blockchains is not only cumbersome, it's not user-friendly, it's costly, and it lacks security amongst bridges. Furthermore, any sort of native assets are restricted to stay on the blockchain that it's built on. So at ZK Link, what we've done is that we've created the first aggregated rollup infrastructure to connect blockchains together and to solve the fragmented liquidity problem for high-scale, high-performance ZK applications. In other words, we offer developers a single deployment point to very easily connect to multiple layer 2s, and we secure them with ZK proofs. To a user, it'll feel like they're acting and interacting with a single chain, but with the added benefit of liquidity and assets across hundreds and thousands of blockchains. So let's get on to it, and let me show you how this works. So very quickly, what is an aggregated rollup? What is an aggregated layer 3? It's a scaling layer that aggregates liquidity across any ETH layer 2 rollup. Like how layer 2s act as the side road for Ethereum, the layer 3 here is the highway that connects all of the side roads back onto Ethereum and onto the other layer 2s as well. The important thing here is that it uses ZK snarks for multi-rollup state synchronization. We use Plonk as our ZK snark, and we have a host chain hosted on Linear to help us out with the multi-rollup state synchronization. In essence, we're a ZK rollup of Ethereum layer 2s, and this creates a zero gas fee environment for all of our users. It gives them access to limitless liquidity, better security, and faster finality times with better UX. So here's a very quick description of one of our products, which is ZK Link Nova. It is the first aggregated layer 3 ZK EVM network We just launched earlier this Monday, and right now we have about 31 million in TVL, and we've got over, I think, 10,000 different users already on chain. So what are the key features here that we have? We've got a ZK EVM rollup. We are able to bridge, we're stack agnostic, meaning that we can aggregate liquidity across any ZK stack, OP, and ZK. So we can aggregate from OP Superchain, Polygon's Ag layer, ZK Sync's Hyperbridge. Because we use ZK proofs, we've got the inherited Ethereum security and our execution. And when you break it down, the architecture, we have the execution layer using ZK stack from ZK Sync. And on the execution layer, on the settlement layer, we've got ZK-Link Nexus doing the aggregations and the ZK proofs. So this is what the Nexus solution, which is our settlement layer, looks like. We have the host chain. We have the host chain doing the transactions, which then goes onto Linear to do the multi-state synchronization. The state synchronization happens through the transaction hashes using the batch root of the transaction hashes, and it then settles on Ethereum. So there's some of the tractions that we've had. We've got over 405,000 Twitter followers, 300 Discord followers, and a healthy 13,000 newsletter subscribers. There is huge demand for us, especially amongst the layer 2 solutions, and also dApps who are looking to have a more connected ecosystem within the blockchain. In our ecosystem, we have approximately 120 strategic partnerships already. It continues to grow daily. We are integrated with 17 networks across both Nova and X.
Please note,
so right
we
now,
have
we're
1 minute
finishing
left.
our Nova mainnet, and we're integrating a modular DA solution for the Nova network, also supporting with a ZK Oracle for our other rollup, ZK-Link X. So this is the tokenomics utility model. We mainly use it for governance. It's going to be for proof verification, and also the gas, and also the infra rollup licensing fee. At the moment, we've got an ecosystem grants program, giving out 50,000 ZKL per project. And if you've been paying attention to what's going on so far in crypto, ZK-Link has just launched a liquidity mining yield campaign going on literally right now. We just launched 3 hours ago. We are the only aggregated layer 3 with added yield for layer 2 native assets, stablecoins, Ethereum, LSTs, LRTs, LSDs. If you're interested in participating in this, let me know. I'll shoot you a DM code afterwards. You can find me on Telegram at ZKNeil. And once again, thank you, and thank you for listening in. And I hope that you've had some value from this presentation. Thank you very much.
Wonderful, right on time. Many thanks for your top-notch showcase, and congratulations on your recent launch. My pleasure. And let's see if we have a few questions coming up from our judges. We have a question from Laurie Peltonen. What kind of delays are there for using your system across blockchains?
I'm sorry, what kind of what?
Delays.
What kind of delays are?
Let me elaborate on it again. What kind of delays are there for using your system across blockchains? So across several blockchains, I assume. If you can answer the question, of course.
Okay. To be honest, on a layer 3, what's really cool about the layer 3 platform is that we're using ZK stack. We're using a ZK EVM. The key here is that it's ZK, meaning, and in terms of performance, it's one of the fastest, if not the fastest, available solution on blockchain. On top of that, now that you've got the fastest performance ecosystem on layer 3, you are also aggregating liquidity. You're also accessing liquidity across all of the other connected layer 2 rollups on both Optimism, using both Optimism and ZK stacks. So the delays are essentially minimal. I think on paper, the TPS, it could go up to 100,000 TPS, no problem. But that requires a application-specific build, which we provide with zk-Link X, with our zk-Link X rollup solution. Right now, we're in the middle of launching the general-purpose zk-Link Nova, and that one is that one you can get a little bit higher, but we balance out performance for connectivity.
Lovely. Thank you for elaborating on that. I see Laurie has one more question. Please don't take it personal. We are tight on time and have other judges also. So I'm going to move to the next judge. Got a question from Florian Kluge from Mina Protocol and 001 Labs. Does zk-Link connect only Ethereum layer 2s, or are there also EVM or non-EVM chains connected or planned to do so?
At the moment, we are only connected to EVM chains, mainly because we use the ZK EVM, mainly because we use ZK proofs for the rebalancing of the assets. So so anything to do with EVM. We do have plans to bridge later on, to access liquidity, to aggregate liquidity from Solana, and the other popular chains like the Suis, your Sais, your Bera chains. That's in the works, but for now, it's only on the ZK and EVM type of networks. Sorry, and OP as well.
Awesome. Well, thank you for sharing. We have time for one more question. We got one from Moet from Elf Blockchain. Who pays for the users if you don't charge any gas fee? Is that a sustainable model in your view?
All right. So for the user, because it's free, yes, you're right to say that there is some gas somewhere. The short answer is that it's paid by the dApp here. There is a proof, a verification, and generation service that needs to be accounted for, and that is borne by the dApps, right? The kind of way that we balance the model out here is that instead of having the dApps to pay the heavy amount of resources to do multi-chain transactions, we instead give them a plug-and-play model when they get onto layer 3. We have the ZKL token, which allows for connections to multiple chains through a pay-as-you-go service. It's sort of like a SaaS kind of like a model where, if you want to access 10 chains, you pay a certain amount of ZKL and you have access to it.
Wonderful. Thank you so much for the brief update. We're also out of time, so many thanks for being with us again. I also got to share, I was quite mind blown. There was a sale recently on CoinList and you managed to sell out within 1 minute. So amazing achievement. You guys are building something very cool.
It was at 25 minutes. I got to correct you there. It was 25 minutes. But we were one of the fastest in CoinList's recent history. And we raised, I think, about $4.68 million.
Wow, that's very remarkable. Amazing, Neil. Looking forward to shape you further and wish you a wonderful day. Thank you.
Thank you.
All right, so we will be moving to the next showcase. This is a very special one from Gevolut. This is a highly anticipated project, and I'm very excited to bring Norbert on stage. So please get ready. Hi, Norbert. Welcome.
Hi, Kaya. Hi, everyone. Thanks for the opportunity to be here.
A big pleasure to have you on. I will share now your screen, and you may kick off your showcase.
Thank you. Hi, everyone. This is Norbert from Gevolut. I'm doing protocol research, and I'd like to present you today the internet scale compute for zero-knowledge proofs. Gevolut is a decentralized prover layer exclusively optimized for zero-knowledge proof generation and verification, and we can legitimately compete with centralized options in both speed and cost. We are cheap because we are aggregating proving workloads from all across the industry. We are performant because we don't have overhead, only a minimal one, and we are exclusively optimized for proving and verification. And we are flexible because anyone can deploy any arbitrary prover system permissionlessly on Gevolut. A little bit about our network overview. So just like you deploy a smart contract on Ethereum, the same way you can deploy prover and verifier programs on Gevulot. Users, which can be any application who is requiring ZK proofs, can submit their proof requests to us, to the designated proof system deployed on Gevulot. Our network will process the requests and send back the proof to the requester. And the underlying blockchain will actually make sure that workloads are distributed in a fair manner, rewards are distributed again in a fair manner, and it is going to process all the transactions, transfers, staking, and proof system deployments. A little bit about our network actors. Our validator set is processing the transactions, broadcasting the workloads to provers, forming consensus on replicated state. And each block, there is a leader selected who is taking care of order selection, transaction ordering, and then making sure consensus is reached. Provers are generating proofs and verifying them as well. So a subset of provers is taking care of the proof generation, and then all provers are participating in the verification. To enter our prover set, the provers need to be staked, but we also verify their capacity at their initial joining, and then randomly, periodically, to make sure that our prover set, whoever is part of our prover set, is active and still capable of generating the proofs timely. We use random selection to distribute workloads. Users can define the required redundancy, and we also apply backup mechanisms to ensure liveness guarantees hold. So on a high level, our process flow looks like this. Users submit workloads, the validators process these workload transactions and broadcast them to provers. A subset of provers, randomly selected, will generate the proof and submit it to the mempool. All provers will verify the proofs. But as soon as the proofs are already in the mempool, they can be also shared with the requester. Once two-thirds of verified, like two-thirds of our provers have verified the proof, it is bundled into a block and then reaches finality on Gevulot. However, the user can already use the proof and have it verified on L1 or whichever other layer they prefer to. The proving lifecycle looks like this in the example of a validity rollup. So users submit transactions, the sequencer bundles them into a block, submits a proof request to the proof system on Gevulot. We generate the proof, send it back to the sequencer who can use it and have it verified. And in the meantime, it gets also verified on Gevulot, ordered into a block, and then provers are paid their rewards. Our DevNet is launching in a week and a half, 25th of March. We had 16K signups, a total pipeline of almost 300 projects. More than 100 projects have already been onboarded. And actually, we've got participation from key partners like Starkware, STech, Axiom, Scroll, Lagrange, and so on. Our roadmap also includes an incentivized testnet toward the end of in mid-2024. And then towards the end of 2024, we are looking to launch our mainnet as well. If you are curious about Gevulot, feel free to visit our website or hit the QR code to see how you can join our DevNet. Thank you very much.
Wow, thank you so much. That was a remarkable showcase, Norbert. While the judges are typing, the judges already casted questions. We got one from Laurie again. Is proof verification only an internal process, or is there a reason why someone would submit their own proof for your network to verify?
Proof verification is partially an internal process. So it is needed for us to make sure that whoever we distribute rewards to have actually generated a valid proof that can be verified. If users want to, they can have their proof verified on Gevulot instead of an underlying other blockchain, for example, instead of having it verified on L1 Ethereum, for example. But yes, so it serves both purposes. One of them internal and also external, but users are not mandated to actually have it verified with us. So as soon as the proof is generated and available, then we send it to the user, who can already further utilize it as needed in their process design.
Wonderful. We have one more question coming up from Michael Berg from Aurora. How does the system interact with DA? Do proof systems have DAs associated with them, and do proofers submit updates to the DAs?
Actually, we don't tie our users to actually any DA layer. Our provers will actually store the proofs that we have generated. However, it's up to the users to decide whichever DA layer they wish to utilize. As soon as they got back the verified and the valid proof from us, they can basically have it stored wherever they feel fit. On the other hand, we are also going to be partnering with some DA layers to add an additional element to the modular stack.
Very impressive. Another question coming up from Mohit from Alf Blockchain. Proof generation is already time consuming. What are your plans for scaling the decentralized proof generation for better user experience?
So for better user experience, I think it's important that currently the largest bottleneck is actually the cost. So we are looking to bring down the cost by an order of magnitude, actually, compared to what's currently out there, at least 50% compared to current cloud providers, for example. So we want our proofs to be absolutely cheap by at least a mile than the industry. And what we are looking to do is, instead of cloud, we are looking to utilize data centers. We are looking to optimize both at hardware level and also at software level. And with like reaching economies of scale and aggregating workloads from any L2s, ZK coprocessors, any ZK dApps, anyone who is actually in need of ZK proofs, we are looking to reach economies of scale and thus really provide performance at low cost.
Wonderful. A little fun fact, we actually have two ZK hardware heavyweights on board today. We got Ingonyama and Saisek, so hopefully they can contribute on your mission. We got one more question coming up, and that's also the final question. One from Adrian from Audit One. You were mentioning that you are onboarding 100 plus projects across industries. Which industries are mostly present at this point?
I think there is quite a good balance, but I would say probably ZK L2s, coprocessors also, and some ZK dApps. But I think the largest interest is from L2s, as the demand for ZK proofs is the highest on that front.
Understood. Well, thank you so much for elaborating on that and for being with us today. It's a
Thank you
big
very much
pleasure.
for the opportunity.
Our pleasure. Have a good day, Norbert. Goodbye.
Same to you.
All right, so we will be moving on to the third showcase with David from ZKMe. So please get ready, as I'm about to bring you on the stage. Yes,
Hey,
sir.
Kaya. Thanks for having us.
Our pleasure, Alex. Great to have you on today. I will directly bring your slide on the stage and you may kick off your pitch.
Perfect. Thanks so much. I mean, maybe some of you have already heard of us. ZKMe, we're an identity layer. We leverage client-side generated zero-knowledge proofs in order to verify user credentials. And the main reason why we have to do this is for three different main top-level problems that we aim to solve in decentralized identity. So one of them is that if we have a future in which we have maybe, as mentioned in previous pitches, hundreds or thousands of different chains, how do we ensure that identity within these chains is interoperable, that a user doesn't have to re-KYC or reprove that they are a high-value user among all of these chains? Then another thing that we solve for is for identity misuse and theft. Every year, hundreds of millions of user credentials are stolen, misused, because they are stored in a centralized big honeypot of a database that can be hacked, that can be stolen or misused. We anonymize and pseudonymize data directly on the client device. That's why identity misuse cannot really happen. And then probably most importantly, we solve for regulatory compliance. Regulatory compliance not only on a front-end level, but really natively on a smart contract level. Since most regulators around the world are currently becoming active in redefining what financial services fall under what kind of regulatory scope, we see that more and more smart contract-based financial services actually do fall within existing regulatory requirements, especially in the European Union. I think that's a fact that most of the industry is currently underestimating. It very clearly says that any service provider that has any centralized component will have to fulfill existing customer due diligence processes. So that could mean that, for example, a layer 1, a layer 2, even a wallet provider will have to KYC every single wallet that is interacting with that chain. And we believe the only way for what we really value, for decentralized finance to become mass adopted and become something that is used by not a couple of million of users, but potentially hundreds of millions of users, it needs some form of verification that is lightweight, that fulfills regulatory compliance, but at the same time also stays true to the ethos of Web3, meaning is decentralized and values the privacy of the user. And that's why we suggest the idea of a ZK-powered identity oracle that leverages client-side generated zero-knowledge proofs in order to generate some kind of attestation that can be consumed on-chain without having to trust a centralized entity that bridges and owns the identity of the user. In order to explain how this works, bear with me, very high-level conceptual explainer. So usually when you have a triangle of trust, you have the following setup. Holder and verifier, like an end user and maybe a financial service provider, don't really trust each other. So they have to rely on the trust pursued by a third party, the issuer. In most cases, it works like this, that the issuer has some form of database in which they store data like credentials. Maybe this data is even encrypted and makes this kind of data available, like these kind of credentials available to the verifier. But we say this doesn't really work. It doesn't really work for the problem statement that we have. Many different ecosystems, something that happens on chain, something that is transparent on chain. So we say, let's get rid of that issuer. Let's trust code. Let's trust the user to self-verify. Just like a layer 2 can verify that certain transactions happened to an underlying chain using zero-knowledge proofs, we're going to enable and allow the user to self-verify certain credentials that they have access to through the use of zero-knowledge proofs. So they would disclose only eligibility, yes or no's, for example, saying the user's over 18, the user's not on any sanctions list, the user is not involved in any suspicious activity, without having to disclose the underlying fact itself. But in order for this to become a truly legal solution, as some of you know, in KYC, you need to do two things. You need to allow for a risk evaluation before onboarding a user, and you need to have legal enforceability in case an actor is involved in some criminal activity. So what we do, the second output that the user generates is a data registry protected through threshold encryption that is stored on decentralized storage. that can only be recovered in case of bad actor proceedings. So just like a multi-signature, several stakeholders within this setup have to agree to remove the anonymity of the user. So in this kind of setup, the user truly stays anonymous until proven guilty, thus fulfilling the legal requirements without compromising on decentralization and privacy.
Please note
This is
you
also
have
the
1
first
minute
use case
left.
that we took live. So ZK-KYC is a use case that we took live approximately 6 months ago. There's a demo, but in the interest of time, I'm going to skip it. Focus a little bit on what our most important design considerations are, allowing the highest degree of compliance with the lowest amount of friction, and with the highest degree of zero knowledge. So to make it sure that it's as end-to-end zero knowledge as technically possible at the moment. Value proposition, it's the cheapest way of verifying users. Not only is it the most private way of using it, and most importantly for the user, it's the only solution that is ultimately private because no party besides the user accesses data, while in the future also allowing for a data economy in which the user is in control who consumes what kind of user data and for what kind of purpose. All of this is live, and I'm welcoming anyone here to just try it, either by downloading the app or going to app.zk.me. So far, going live 6 months ago, we're happy that we have over 45 customers live with our solution. And as of yesterday, we crossed the 410,000 user credentials attested, which should make us one of the biggest on-chain KYC providers.
Wow, congratulations, Alex. Thank you so much for your top-notch showcase. We have also a question coming up from Florian Kluge from Mina Protocol and O1 Labs, and I will bring him actually on the stage. So, Florian, welcome.
Hey, thank you for having me. How are you? Do have a quick question. You mentioned that code.
You're a little bit quiet. I don't know if it's on my side. Could you speak up a little bit?
Likewise.
Still very quiet, sorry.
Oh, I can try to get a bit closer, maybe.
This is good.
Perfect. Thank you so much.
You mentioned that code acts as an issuer of
Yes.
your data in KYC. Could you briefly explain how exactly that works and how do you prevent, or how do you secure that the data that's actually going into the proof is really from a trusted source, let's say like a government or something like that?
I mean, the trusted source, you have to distinguish different data sources. So for data sources that come from the internet, we partnered together with a provider called Reclaim in order to do free-party TLS proof generation. But most of the data actually comes from physical devices. So what we do, for example, for a passport is we physically scan the passport page, generate the key that is required to read the NFC chip on the passport, and then generate a zero-knowledge proof out of the data extracted from the NFC chip in the passport. And yes, while the solution is not fully end-to-end zero-knowledge, it's not the whole machine learning algorithm that recognizes faces and recognizes fake is encapsulated into a zero-knowledge proof yet. Certain critical components are, so we can detect whether the user, is tampering with the input, like the witness generation.
Thank you so much for elaborating and your time, Florian. All right, so we have one more question coming up from the prominent Paul Taylor. He is an heavyweight as an angel investor and advisor, but actually also a venture partner of BlackRock. His question is, how are you continually verifying KYC AML requirements over time? For example, if someone may pass KYC, but circumstances may change over time.
Very good question. And we take a little bit of a, we take an approach in which we say it's up to our customers to decide in what kind of interval credentials need to be renewed. We do disclose to our customers how long ago a certain credential has been verified. And then there's like two things that the customer can do: either guide the user through a renewal, like they have to re-KYC and thus, getting an approval, or they could initiate things like on-chain AML that do not require the user to re-KYC. So it depends a little bit on our customers, but we do highlight to our customers, and we typically tell our DeFi customers to renew a credential every 12 months. That seems to be a good middle ground at the moment.
Wonderful. Thank you for clarifying. We have room for one more question from Mohit from Elf Blockchain, and I'm bringing him actually on the stage. Welcome, Mohit.
Hi, Alex. So
Hey,
I
Mohit.
saw that the solution is similar to Polygon ID. So what is the exact differentiation, and what is your strategy to compete with such a player?
We actually do not compete with Polygon ID. Like we actually also deploy on Polygon ID. Like the way I see it, Polygon ID is a format and a standard. We focus more on the data provenance. Like there are existing KYC providers on top of Polygon ID that do a centralized KYC. They have data ownership, they store the data, and then just publish the result on chain. What we do is we extend the idea of Polygon ID into the data collection itself. So we don't exist as a company. None of our employees looks at data of the user, and can also not look at data of the user.
Okay, thank you.
Yes, thank you, Mohit. Well, Alex, thank you so much for being with us today. We're also out of time, so I wish you the best with further development, and wish you a great day.
Thank you, Kaya. Thank you so much for having us.
My pleasure. All right, so we will be moving to the fourth showcase. We have Paddle Labs with Fubio, who has been actually already twice at Pitch Talk, and I'm so happy to bring him back on stage. So Fubio, welcome back.
Hi, Kaya. Yeah.
Yes, awesome. Could you please share your slide?
Yeah, I trying to upload the slides, and it's still in processing. All right, I see.
Oh, yeah. There it is. All right, bring it on now, and you may kick off your showcase. Thank you.
Right.
Wonderful. You may kick off now.
Yeah, it looks like okay. Okay, thanks. Hi everyone. I'm Fubio, the co-founder and also DevRel from Paddle Labs. So Paddle actually is kind of CK attestation protocol in our first stage, but I'm not going to tell you about anything about the attestation, which we have already done that. And this is our next step. We would like to build Paddle as a zk-FHE-based decentralized computation network. So some background is, so ZK and FHE. So we know both zero-knowledge proof and fully homomorphic encryption are very powerful cryptographic primitives. And we think both of them have different drawbacks. So for example, like FHE, people use that to do arbitrary computation on the inquiry data, which is very powerful, and you can use different applications, like you can put FHE in the outsourced computation. But the problem is, in this kind of outsourced computation, the client will first send his inquiry data to the worker. The worker will run some computation task based on that. And the problem here is, how can we make sure the worker do that job correctly or honestly? So actually, you have no idea to distinguish a random response from the worker, or maybe the worker is doing it correctly. So yeah, here's the problem. Here means the client has to trust the worker in terms of the computation integrity. And in the zero-knowledge proof side, the integrity is not a big issue. Basically, we know the zero-knowledge proof can be used in the off-chain computation, and the integrity is naturally guaranteed by the property of CK, like soundness. But here, the problem is, if the user want to delegate his witness or his private data to some some worker, then there will be the privacy issue comes up. So which means if the worker has no idea of what kind of private knowledge is, he cannot correctly generate the proof. So with this kind of observation, our idea is we can use a new thing called ZKFHE. So ZKFHE is not simply combine these two things together, but you have to redesign and thinking from scratch. So we were trying to provide a ZKFHE solution to address these kind of challenges. So in the ZKFHE solution, the client can just send his encrypted input to the worker, just like in the FHE mode. But the worker, besides he just doing his computation based on that encrypted input, he still need to do some proof on that. And that output proof will be verified by the client to make sure that computation result is correctly derived from the required computation task. And only the proof is verified, the client will do the decryption on that result. So in that case, the computation integrity is ensured within such kind of ZKFHE protocol, and also the privacy is also well preserved based on this FHE solution. So of course, there will be a lot of technical challenges in that, and some existing methods may lack of generality and efficiency. For example, people could use this their FHE code and compile it into the ZKVM to come up with some simple operations. And most of that approach will fall into the slow performance or take a long time to prove that. And our idea is we're trying to do the core component within the FHE scheme. We're trying to prove the bootstrapping operation, which is the most significant component of FHE scheme, and we're trying to improve that. So yeah, we can do that in just in a few seconds, and we are still able to improve that operation. With our ZKFHE solution, we can build a decentralized computation network with that component. And the idea is the user can first connect with their web data source and using the Pado's existing attestation technique to attest their web data. So here, the attestation means the ZK attestation, which using some cool protocol like interactive without proof or multi-party computation based on the TLS transport layer security protocol. And why is attestation is very important here is because we need to ensure the user's private data before that data come into that network is authentic. So which means the user can first attest their web data and retrieve their web data locally, and then they can share that data into the network. And
please note you have 1 minute left.
Okay, yeah, and here we will using some hardware acceleration solution to optimize our underlying ZKFHE protocol. And once their data come into this network, they can using our computation network to do arbitrary computation tasks based on the application's requirements. And of course, we will leverage the smart contract to make sure the user can just simply gain some benefits from that approach, and they just make sure that their private data is stored in different storage blockchain. And of course, the whole solution will use a modular blockchain like Agent Layer to share the whole the full security of the whole Ethereum ecosystem. So yeah, just some use cases include here, like we can using this ZKFHE to do some kind of data exchange based on the storage blockchain, and also we can put that in different kind of MEV or auto broadcast situation, and to make sure the privacy is well protected. And even we can just use this technology to do some machine learning jobs, and also use in the deeping situation. Yeah. So yeah, this is pretty much about our next step using the ZKFHE to build the computation network. And our team has got some achievements, like got some grant from the Eastern Foundation and accepted by different accelerators. Yeah. So this is pretty much about the introduction. Yeah, thanks.
Many thanks, Fubio. We have a few questions coming up. One from Leo from SciSec, who is actually one of your ZK hardware partner with Ngonyama. Are you running ZK on top of the FHE operations? The overhead seems prohibitive.
Yes, yeah, that's a good question. Yes, yeah, we know that. I mean, combine the ZK into the FHE. It's not simply you run some ZK snarks or doing some kind of engineering work, but we need to design the whole academic scheme from scratch. Yes, to be honest, the whole cost is very. I mean, it's not like it's a very easy way to do that, but we're trying to optimize from scratch. Like I said, we can using some technologies like some check in the ZK and some problems need to figure out. Like you because FHE may using some kind of different finite fields with the ZK, so there are a lot of detailed technologies. Technical issues need to figure it out. Yeah, but we definitely we will just approve your FHE operation by the ZK. I mean, just equip that ZK into that operation. Yeah.
Thank you for elaborating. I will also give a question to Alexander from Polygon ID. Would it be possible to process personal data? Can you give example of such use cases, if it's possible, of course?
All right. Okay. Yeah, about the personal data. So yeah, actually, Pado have already deployed on the Polygon ID with the Polygon DID framework. So in that use case, we're just using our attestation solution to make sure that Polygon ID users can provide us their off-chain web data. And the Pado in that framework will more like a attestation issuer. We're trying to help the user to generate their authentic attestation to that framework, and they can just use the Polygon ID wallet to download and scan that, and using different kind of off-chain situation. Yeah. Okay. I think it's more like the attestation. Yeah.
Got it. And we have one more question from Michael from Aurora. What SDK exists to allow developers to write applications that run in this ZK-FHE?
Okay, yeah, that's a good question. Actually, we are actually there are no SDK right now. We are still in the progress of optimizing our ZK-FHE protocol, and we hope we can publish the protocol. And I think in the middle of this year, and we will trying to do some engineering work on that developers toolkits to make sure this capability can be used by the builders.
Many thanks for clarifying. We have time for one more question. Could you elaborate on privacy preserving ML?
Oh yeah, I think yes. Talking about the machine learning, so actually there's a lot of crypto technology can use to do the PPML. I mean the privacy preserving machine learning, and FHE is one of them. And the ZK-FHE solution can be used to do the traditional machine learning, just like people using that in the traditional PET technology as well. So, but here I think the idea is we can use that in some prop situation, like you can do a model inference rather than you use that heavy technology in some training process, like with several. Like 50 layers of deep learning model, or just using that in the large language model. But I think I just come up with some FHE demo, which people using the FHE solution to do the to like the LLM, like the inference in the LLM. I mean, using some very nice code, just plug it into the GPT-2 model and do something which is very efficient. So yeah, we think this. I mean, theoretically we can do that, but still need to do a lot of crypto research and engineering optimization for that area.
Thank you so much. We're also out of time. It's a big pleasure to have a big brain, a PhD in cryptography on board. So Fubio, thank you so much for being with us again, and have a good one.
Okay, thank you guys.
All right, so we will be moving up to the next showcase. We got a Veil wallet with Zach. So please, Zach, get ready as I'm about to bring you on the stage. Yes, sir. Welcome, Zach.
Hello. Let
Hey.
me start. I start presenting, right?
Please share your screen and we can kick off.
Yep. 1 second. Okay, let's go.
Let's go.
I am Zach, founder and CEO at Avail, where we're building a wallet that gives people full ownership of their money and data whilst preserving their privacy. Full ownership is like real estate. When you have a property, you have the key to the property, and only you have access to it, unless you give the key to other people. But when it comes to our money and data, we delegate this ownership. We give the key to the bank, and we give our data to the big tech companies. And this means we have to trust them. And this causes FTX, Silicon Valley Bank, and several others. And when it comes to data, I don't know how many KYCs you had to do this year, but online identity theft is getting quite big. This metric's from 2022, but it cost $43 billion for 40 million adults in the US. So my question really to you is, why must we fail with them, with these big institutions? And this is what we are solving at Avail through building on Alio, the first private programmable layer 1 blockchain, which uses zero-knowledge proofs and on-chain encryption to preserve privacy completely. They enable people to have full ownership of their money and data whilst preserving their privacy. But for this to be used and integrated into everyone's day-to-day lives, and people can actually use this technology, this has to be made seamless. And to do this, we are making wallet recovery simpler, such that you don't need to store a seed phrase. We are taking those zero-knowledge proofs that need to be computed off-chain and delegating that work to more powerful machines. We, as ZKM me said before, there are these identity authentication systems coming up using zero-knowledge proofs, one of them being ZPass, a protocol developed by Alio themselves. And we are creating an issuance system for this. We are also partnering with Alchemy Pay for on-ramp, off-ramp to allow for easy crypto to fiat exchange, and Weaver, which is an EMI licensed institution to allow for IBANs and debit cards, to allow for users to transact and receive, so pay and receive, with people who are not on the network. And we have also identified a problem with legal contracts. They're slow, they're expensive, and payments and data transfers are separate, which means yet again, you have to include another intermediary in whatever you're trying to do. And we solve this by combining legal contracts and smart contracts to create seamless agreements that are more cost effective and time efficient, which means you can make a legal contract within minutes and also handle the payments at the same time. Our team has technical expertise in application development, blockchain development, legal frameworks, and strategic marketing. Our go-to-market strategy is as follows. We'll start with the Alio community, since we support that chain natively right now. We'll then, at the same time, target the other 90% of blockchains that are public, which means the data is public, and educate these people that they have an option to preserve their privacy while still getting the benefits of crypto and blockchain. And then we will target freelancers in the EU with our contracts feature and allowing for client invoicing and management. Same with enterprises, taking it as another step further. And then global remittance, which is international money transfers, making it so that a money transfer to Japan is the same as a money transfer to America, as it should be, and the fee is the same. And also the privacy is preserved, and anyone really looking for secure and easy money and data management. Our business model is a freemium model, and we will charge fees on select services and experiences within the platform. And we will offer more premium subscriptions to individuals and businesses like freelancers and enterprise. So that's the deck. And now I'll give a bit of a demo of the wallet application. So this is on my Mac. We launched this. This is the desktop app, by the way. We launched it about 3 weeks ago. Have around 500, 600 users, but it's really about gathering feedback right now. So this is the home page. It's on testnet, so Alio's on testnet. We have 6 private Alio tokens and 8 public. I can go and send to someone, so I want to send 2 tokens. I'll send to Julian, who's part of the team, as you saw. They have unique identifiers like that, and I can say, hey, what's up? And of course, fully private. And we can send that. Transfer is now in progress. And that's the zero-knowledge proof computing on my device. It should take a few seconds. Once it's done, we'll see it pending. And let's try it. We'll try it again really quick. Julian 9556. And I'll say hey. And this time, let's leave the fee public. It might be an issue with the private data, but this should work. We'll list it in the bugs list. Let's see if this one works. Give us a second. Should go to pending soon. Anytime now. Let's see. Yep. And that will be confirming soon on chain. We'll go to the browser now, where we have integrated several dApps from the Alio ecosystem, including Arcane, which is the next pitch up. It's an exchange on Alio. Can connect our wallet here. Connect. This pops up. I'll approve the connection. Then we'll approve. This basically they're getting our private balance, because of course an exchange on a fully private network does not have access to your balance. And you can see here we have 4 because we spent 2 earlier. And now we can go, for example, and issue if we want some USDT, claim. So we're minting some here. And that's the inputs to the program. The program is a smart contract on Alio, and I'll approve that. And if we go home, we'll see that that's processing. And that'll be done in a few seconds. That's scanning the chain's encrypted data that was executed. And I think that's good. It's just to give a bit of an experience of what it would be like.
Yeah, wonderful. Thank you so much, Zach. It seems to be often a curse at our demo days when people show a demo that this happens, but it's actually great to see a
It's
demo.
okay.
Thank you. I'm happy to share that we have a question from Alexander from Polygon ID, and he will be joining us on stage. Welcome, Alexander.
Hello. Hi. Can you tell me what happens if user loses control over his private key? So you said that there is some data encrypted on chain. So what happens? Is there some countermeasures from decrypting this data by someone else?
If someone gets the user's private key,
yeah,
there are no countermeasures here. If they get your private key, they get your private key. They get everything.
Okay. Okay. Thank you.
Thank you, Alexander, and thank you for the honest question answer.
That's how it is.
Indeed. So hopefully we can find a mechanism to counteract this in the nearest future.
I mean, more secure storage. There's not. It's your key is your key. It's on the developers to make the storage secure.
Absolutely, fair enough. Well, get ready. You have a captivating mission because there are many more questions. We got one from Michael from Aurora. In what jurisdictions are these seamless agreements enforceable? There is still a trust assumption that the legal system of that jurisdiction will uphold the contract.
Yes. So we're taking this jurisdiction by jurisdiction. if we support a jurisdiction, that means we got the lawyers from that jurisdiction to make the standard contracts behind the framework we use to then automate these agreements. Currently, we have Malta and the United Kingdom, so England, and we are targeting other countries in the EU. That is why we will target freelancers in the EU first. We work with these lawyers to see that these contracts will hold up in court. So that's exactly why we go directly to them and we take this jurisdiction by jurisdiction approach.
Understood. We have one more question from Adrian from Audit One. What is your go-to-market strategy? You mentioned Alio. How will you leverage its ecosystem?
By going to these community events, being active on socials and on Discord. We have a Discord with about 7,000 members. We're active in the community. We're ambassadors of Alio ourselves. So we do presentations to help people learn about Alio and just being a part of the community and growing it. But as I said, I think in the presentation, it goes much further than that. There's a lot of education to be done outside of Alio to educate people that there is this privacy option. And truly, like, this is a ZK demo day. And when people use ZK, it's a lot of like, it's not always privacy. I think the minority are actually privacy preserving in Zero-Knowledge. So people need to understand this, and maybe by making the user experience better, we can approach more people.
Awesome. We have one more question from Taihoon from Lightschool and Chroma Network. If I use Alchemy Pay to on-off ramp, can everything still be private?
Yeah, so they have, yes, the answer to your question is yes, but it requires some more work from our side, and we are seeing that happens. So yes, it can. Yes, it can.
Wonderful. We're also out of time. So Zach, thank you so much for being with us.
I just want to say one more really quick. We are currently fundraising. So yeah, we're raising around 500,000 to continue developing this technology and enable us to hit the milestones that I explained and reach those go-to-market and execute that go-to-market strategy. So thank you, Kaya, and thank you everyone for listening in. Have a pleasant day.
Our pleasure. Good day. All right, so we will be moving to the next showcase with Arcane Finance. Please, Maxime, get ready as I'm about to bring you on the stage.
Hello, hello. Can you hear me?
Yes, loud and clear. Welcome, Max.
Yeah, great to meet you.
Likewise, I see your slide in the pre-stage. I'm bringing it on now, and you may immediately kick off your showcase. Thank you.
Fantastic. Thank you. So yeah, my name is Max, and I'm a co-founder of Arcane Finance, fully private decentralized exchange and a central liquidity hub on Alio. Yeah, so basically, we think that the world of Web3 finance today is totally broken, as well. Everyone can see everything in blockchain explorers, like what's happening, and this makes people very susceptible to MEV attacks, and basically it's like lack of privacy, lack of anonymity. We think this is like a basic right of everyone to remain anonymous if they want to, at least anonymous from public. And well, at the same time, so people cannot exchange their funds privately on DEXs, and they have to go on centralized exchanges to do that, which, well, they have their own problems. So they are insecure, they're centralized, and your money can always be blocked or stolen. We know what happened to FTX, and like happens once in several years. And centralized exchanges also provide privacy from public, but at the same time, some unfair internal actors can spy on you and also front run your trades too. And well, we think it is time to fix that. And our solution is Arcane Finance, which is a fully private, decentralized exchange powered by zero-knowledge proofs and built on Alio blockchain. So basically, what is Arcane from user perspective? So there are several trading models supported in our fully on-chain exchange. So it's a request for quote model, where the orders are fulfilled by professional market makers. And it's also a concentrated liquidity AMM, kind of a bread and butter of on-chain trading, proven tech. And also we have something completely new that is called dark pools. In dark pools, like everything is private, so it's like both pre-trade privacy and like no one can front run you. And so your order book is essentially private. So when it comes to architecture, so we have like all these mechanisms implemented in our system, but we try to keep it simple for users. So if their goal is just to perform a swap, we just aggregate the data from all these sources and make sure that people get the best price possible. And kind of the ZK part here, so the transactions on Aleo consist of two parts. So the first part is the off-chain ZK kind of powered part, where the code is executed off-chain on a user's machine, so private data never leaves user's machine, and the transaction is executed privately. And then there is a public part where the transaction is finalized on-chain. So what users get by using Arcane, they remain private and anonymous. They can enjoy zero slippage when they do swaps, and there is no counterparty risk when they deal with a centralized exchange. Of course, when we deal with privacy, with on-chain privacy, compliance becomes a very important thing. That's why we are integrating ZK KYC solution, ZPass by Aleo. So that's how we will deal with compliance and stuff like that. Again, just to reiterate, so we are both private and non-custodial, so fully non-custodial, like no way to steal money from users. We see that privacy landscape is getting more attention, so more and more teams come into this space. There are all the solutions like Zcash and Monero, that's basically a private Bitcoin, and there are some newer platforms, infrastructures like Penumbra, DarkFi. They're dealing with DeFi in particular, and our team decided to build on top of another blockchain, so we don't have to build like the blockchain part ourselves. So we can focus on like business side, on product side, and deliver faster than the teams that have to kind of care about like setting up the whole network, securing it, kind of dealing with P2P networking issues and stuff like that. So that's why, from the product side, we are doing both decentralized exchange and dark pool. So why we decided to build an Aleo? As I said, so it has a pretty exciting tech side, fully decentralized, and at the same time private tech, built on ZK. And we also see Aleo being like a major success from business standpoint. And they are we see a lot of interest towards Aleo, extensive VC backing, and that's why we chose this platform, and we will be the central DEX there. So here is our team.
Please note, you have 1 minute left.
1 minute left. Okay, thanks. So we have like a great team. So we built other crypto projects before, so we are covered from all the sides, like from technical to marketing to management to design, everywhere. So try and speed up a little bit. So we have like fully functioning testnet that processed over 100,000 transactions to date. We are the most used protocol on Aleo, and we kind of have a grant from Aleo. We are one of the incentive program winners. So we are the central liquidity hub on Aleo chain. So this slide is dated actually. So we are raising a pre-seed round. So that's more or less it. I see that we are probably out of time. So we are raising 1.2 mil now.
Many thanks for your showcase, Maxime. We have a few questions coming up from our judges. One from Mohit from Alf Blockchain. DEXs should be high performance. What's your approach to achieve high performance? Doesn't private transactions make it more latent?
Yeah, it is true that ZK it's getting faster with each year. We see amazing progress and like different initiatives that help to improve this tech. And well, for now, yeah, we have to admit that currently it's really not the fastest thing. So we are not like targeting kind of high frequency trading or anything like that. So we are targeting like basic human rights to be able to transact privately, to deal with your finance privately. Yeah.
Understood. Thank you for clarifying. Another question from Laurie Peltonen. How do I know what kind of price I can get for my trade if there's no slippage? Is it, for example, liquidity public?
No slippage case is covered by RFQ. So it's you are getting a quote from a market maker that is connected to our system, and well, this quote is cryptographically signed and everything is settled on chain. And again, your trade remains private, but you can see the price. Yeah, you see exactly the price that you will receive if you execute this quote. Yeah.
Many thanks for clarifying. We have room for one more question. One from Michael from Aurora. How is zero slippage possible in a distributed system? Shouldn't raised conditions always make some amount of slippage possible, and failing such transactions could lead to bad user experience?
I see where this question comes from. Yeah, I think I answered it in my previous question. Yeah, it's really kind of almost impossible to achieve this if we are using AMM, just because of the very problem that was mentioned. Yeah, so this would lead to failed transactions, but we are still kind of exploring the design space here. But still no slippage you get if you use RFQ.
Wonderful. I gotta say, we got 30 seconds left, and I saw you at your roadmap. I bring your slides quickly up again and give you a chance in 30 seconds to explain what we can expect in 2024.
In 2024, so we are planning, obviously the biggest plan is to launch our mainnet. This will happen simultaneously with the Alio mainnet launch, which should take place pretty soon. And at the meantime, we are being audited by amazing Veridice team. So half of our product has already been audited. The other half will start audit soon. And also we are working on a dark pool solution. It's slightly more challenging. So it's not fully on chain. It has some another layer on top of Alio, which is again pretty exciting thing on itself. So basically our idea is to roll out the DEX, get liquidity, get traction, and after that we have plans to deliver more financial products on top of that, like perps trading experience, cross-chain trading, and more sophisticated trading models like UniV4-ish hooks and things like that. Yeah, so this is our plan.
Many thanks. I'm a strong believer that private DEXs like yours are key to drive enterprise adoption and yet meet regulatory challenges. So I'm looking forward to see you develop forward. And thanks for your time, Maxim.
Yeah, thanks again for inviting. Yeah, thanks a lot. Bye-bye.
Cheers. All right, so we will be moving on to the next showcase. Actually, Omar is from Noya, one of our winning projects from the Master Blocks Demo Days on Pitch Talk. So please, Omar, get ready as I'm about to bring you on the stage. Yes, welcome back, Omar.
Hello. Hey.
Hey, good.
Thank you for having us.
Our pleasure. Bringing your slide on now, and you may kick off your showcase.
Okay. Perfect. So truly an honor presenting to you guys. I'm from Noya. What we do is something very simple. It's a trustless omni-chain AI agents. So basically, there are multiple problems currently plaguing the DeFi strategy space. It's super time consuming. It's highly technical. Transactions are expensive on L1. People are trusting centralized intermediaries. Liquidity is fragmented. And there are passive treasuries that are doing nothing. We came here to save the day, where we allow AI agents to do basically the work for you, and you don't need to trust them. They trust this using ZKML. They live on multiple chains at the same time. We use very, very secure architecture. We use multiple bridges and DEXs to route liquidity from one chain to another. So why Noya? With our new improved infrastructure, We allow multiple agents with multiple intents to control liquidity. You can use it to aggregate yield. You can use it to minimize borrowing rates. You can use it to optimize for leverage. You can use it to create the first ever omni-chain UniV3 pool. The advancements of Noya allow you to bridge from one chain to another effortlessly in the most fee-minimized manner. The liquidity that you deposit into Noya can be used on all the chains at the same time by using the OFT infrastructure. We can create these amazing innovative vaults like halal vaults, super chain vaults, diversified risk vaults, as I said, the omni-chain Uniswap vaults, and with our architecture is compatible with our V2, which is an intent-compatible infrastructure, where, for example, any user would say, I want to get 5% on USDC on Optimism, but I don't want to use Aave. I only want to use Morpho. With all of these different restrictions and intents in place, we can create a vault specifically just for the user. Noya works in a very simple manner. The user deposits the liquidity, the AI agent places it based on his own model with a ZK proof on a certain chain, and then protocol and asset, of course. And then once there's different change of state, the model updates, the AI agent executes the transaction with the proof, and then liquidity moves from one chain to another. With this infrastructure, we've also added another layer, which is called the Watcher, that watches every single update from the Oracle, every single execution by the Keeper network, and all of the agents, whether or not they are using the correct data from the chain. The market size, of course, is huge. The TVL, DeFi TVL is 105 billion currently, expected to reach 1 trillion in the next 5 years. AI protocols are 20 billion market cap. The ZK protocols are about 23. And our APY, showcases the agent's performance. So we are going to be one of the agents in Noya, but with Noya, any agent can submit proofs and can control liquidity on chain. So it's not limited to us. And here you can see the obvious edge that we can have once we're omni-chain, once we use AI to our advantage. We are currently completing an audit by Hacken. We are going to also do a competition by Cantina. We have done previously 2 independent security audits, and we have our own on-chain watcher that is specifically responsible to watch any fraudulent or possible fraudulent Oracle updates or any fraudulent transactions. With our deposits, they're delayed, as well as withdrawals, to allow all of the different chains to sync up. The AI agents are forced to use verified data optimistically that is proven on-chain. We use multiple distributed decentralized verification networks, Polyhedra with the ZK LAT clients, as well as Layer 0. The execution environment is very boxed and limited to only whitelisted protocols, assets, or chains. We have currently integrated with about 25 protocols. We're going to launch with 10 chains live, with all of the different bridges and DEXs that you can see on the screen, as well as our ZKML infrastructure is compatible with multiple proving systems, whether it's Ezekiel, Modulus, or Giza. The tokenomics are currently very standard. We have 20% for the team. We have 10% that is being frozen for the LBP, as well as a potential future airdrop. Our go-to-market strategy is very simple. It's like a points system, but with seasons. So we have different weeks. Every week, the season submits certain stars, and then the users can compete to get more stars of that different season. As well as we have implemented Web3 CRM within this, so users get emails and Discord notifications if they get a new vault, or if they can get more points and stars. Within our roadmap, it's very exciting because we plan on launching in the next 2 weeks, a very guarded launch, however, and the different protocols that can be built on top of Noya's infrastructure, whether it's the lending aggregation or Uniswap or the tokenized yield, all of them to be built because they're ready in Q3 of 2024, and then hopefully we can build our own specified rollup that allows us to execute, to decentralize that Keeper network even more, and to open source a model creation, basically allow anyone to create their own agents. Hopefully by 2025 we can have restaked models and a marketplace for different agents. So the team is me and my co-founder, the CTO, winner of multiple hackathons. And if you guys have any questions, I'm more than ready to answer them. Thank you. I can't hear you. You're muted, I think.
Ah, yeah, thank you so much. My bad. Thank you for your showcase.
worries.
We got one question from Lori coming up. Higher APY typically reflects higher risk. What kind of extra risk are there in using your system compared to vanilla DeFi?
Yeah, of course. So within our vaults, you specifically have 3 different strategies, whether it's low, medium, or high risk. But what's brilliant about Noya's architecture is that once we introduce intents, you can specify what vaults, assets, and protocols that you trust, and then the AI model would only be work in this boxed execution environment and would optimize to the assets and pools that you specify. So at first, we're going to be the ones who are specifying the vaults, but in the future, anyone can choose any pool, asset, or chain that he trusts.
Wonderful. We got one more burning question from Hugo from Polka Starter. What is the role of the token in the crypto economic design?
Yeah, amazing question. Thank you. So the token is responsible for multiple things because we have built everything from the ground up. So we have an AI oracle. We have a decentralized keeper network. We have these agents that stake liquidity. Of course, the token is going to be used on all of them at the same time. And the very, very simple value accrual mechanism is to take a percentage of that yield or to take a percentage of the borrowing rate that's being incentivized using these agents. But this is just the beginning, of course. And then as we improve, we can improve the utility even more.
Awesome. I see judges typing, so stay tuned. We have room for one more question, or maybe 2. We got one from Emmanuel from Ingonyama. Where are ZK proofs generated?
So the agent themselves, they are the ones that generate the proofs, and they submit them to IPFS, and then the keeper networks verify them on chain, and then execute the transactions after the proof of the model's output has been verified. So you cannot do any transaction unless you have a proof of the model's output that's being published into IPFS.
Thanks for clarifying. As a final question from Michael from Aurora, proving ML inference takes a lot of time, but gains from trading usually require timely interaction with the DEX. How can the AI submit action fast enough if it needs to wait for proofs to generate?
100%, very valid question. We are not looking into high-frequency trading. We're not doing these sub-second trades. We are doing these yield optimizations that usually require hours whenever you want to maneuver. Hopefully, in the next couple of years, proving a billion parameter model is going to take sub-seconds. We're going to use that. But for now, we're using these use cases that require less time, more time to be taken into account.
Thank you so much. We have actually one more question coming up from Francisco, the CBDO of Masterblocks. How do you manage cross-chain smart liquidity so users get the best APY?
Okay, so we use multiple things. So of course you have the messaging relay. We use multiple messaging relays. We have layer 0 coupled with Polyhedron's DK-lat client, which is considered one of the safest ways to relay messages. And at the same time, for value or liquidity transfer, we use multiple bridges and dexes at the same time. So to optimize for value transfer between one chain to another, we're compatible with about 10 to 12 bridges. And the liquidity is smart because we're using this AI agent or AI model that's off-chain, that's proving its output onto IPFS, and the agents are verifying it on-chain. This is how we're creating the smart liquidity. Thank you.
Understood. Omar, thank you for being with us again, and I wish you a great day. Lovely. Cheers. All right, so we will be going to the last showcase. We got Nexera ID with Bogdan. So please, Bogdan, get ready as I'm about to bring you on the stage. Yes, sir. Welcome, Bogdan.
Hello. Hey, how are you?
Doing great. Like a lot of captivating showcases, and I'm eager to experience yours too. So bringing your slide on, and
yes, I'll move them in slideshow mode.
Wonderful.
I'm sharing my screen because I also have a demo at the end, and that will be easier to play from my computer.
Sounds
Hopefully
great.
now you see everything in slideshow mode.
Yeah, you're all set to kick off. Let's go.
Okay, good. Thank you very much. So hello, everyone. I'm Bogdan, head of product at Nexera ID. And today we will be speaking about a topic that's very important for us at Nexera ID, privacy in the Web3 space, and more specifically, privacy-preserving compliance. So we have to start by facing the problem that we have today at the intersection between Web3 and compliance. Web3 is all about data ownership and privacy, while compliance is about gathering as much information about our users as possible and conducting investigations. At Nexera ID, we believe that it is possible to achieve compliance without sacrificing our Web3 values. That is why at Nexera ID, we have constructed a solution that is privacy-centric, that was designed to simplify compliance for Web3 companies. We use verifiable credentials and zero-knowledge proofs in order to enable compliance while still protecting data privacy and data ownership. Our solution was launched 4 months ago, and we have already signed 6 customers, and this adoption is driven by the spread of or expansion of crypto regulation across the world, and especially in Europe with MiCA. But we also see a lot of interest from unregulated businesses such as DeFi protocols, who are very interested about our approach to privacy-preserving compliance, because they know that DeFi regulations are just a matter of time. And our solution was crafted to respond to the needs of both these types of customers, and you will be seeing that in the demo that I will be showing in a second. But before going to the demo, I want to focus on the 3 main pillars of our solution that enable data ownership and privacy. So first, with Nexera ID and with the help of verifiable credentials, users can own their verified real-world identity and reuse it across multiple applications, being in control each time of what exactly they are sharing with the application. By using zero-knowledge proofs, we enable customers to prove specific aspects about their identities without actually sharing any underlying data with the various companies that verify their identities. And finally, with Nexera ID, companies can verify users both in their front ends or back ends, like with traditional compliance solutions, but also on-chain, ensuring that their end-to-end decentralized applications are protected. And now I will be showing you a demo that showcases different facets of our product. And for this, I just made a short recording. So first, we're seeing a user that is interacting with a regulated crypto company and gets onboarded through the use of Nexera ID and the identity widget, which is embedded into this application. And the user goes through a regular KYC process, but at the end, as you can see here, the user signs with his MetaMask wallet, and he's issued verifiable credentials that he will share with the app to get verified, and verifiable credentials that he will be able to reuse later on. The regulated crypto company itself can use their Nexera ID dashboard to gain insights into their customer base and conduct investigations into specific users through the use of a centralized user profile, where they can find the shared verifiable credentials, as well as other screenings that were conducted on the users. And this is absolutely necessary for a regulated Web3 company to have control over this process themselves. But now we see the same user interacting with the DeFi protocol, and this time the user not only doesn't need to go through KYC again, as he can reuse his verifiable credentials, but he will share with the application zero-knowledge proofs to verify his identity. And to get to interact with this gated DeFi protocol. The DeFi protocol itself can also leverage the Nexera ID dashboard to understand their user base, but we can see that this time on a user profile, there was no data that was gathered, as the user was verified through the use of zero-knowledge proofs. And we can only see how the various verifications were executed. And the last part of the demo showcases how easy it is for a company to build zero-knowledge proof requests and verify their users when using Nexera ID. And this is done through the use of our powerful rules engine, which allows to explore the verifiable credentials that users have and build zero-knowledge proof requests based on them. These zero-knowledge proof requests can be deployed and executed either off-chain or directly on-chain and next to the protocol's contract. And with this, I'm concluding this demo, and I'm ready for your questions. Thank you very much.
Yes, wonderful. Thank you so much for your showcase, Bogdan. Let's see if we have a few questions coming up from our judges. Not yet, but I can kick off with one from myself. So what is your biggest milestone so far, and what can we expect in 2024 from Nexera ID?
Yeah, so I would say the biggest milestone for us was the launch and the achievement of this initial customers that we are having. That was very, very important for us. And the moment when we managed to conduct these verifications, both like throughout the extent of a decentralized application up to the on-chain part. And I would say, moving forward, what is important for us is to extend the types of verifications that we showed and extend these types of verifications to companies through privacy-preserving KYB processes. And also open up a customer portal so that our customers can leverage and work with the verifiable credentials that they have received from us outside of onboarding process. Because right now we started with the issuance of the verifiable credentials, their verifications directly through a widget that gets embedded into each applications, because that was what was streamlining the onboarding much more. But now that our customers our end users start to have verifiable credentials, we want to help them make the most out of them.
Understood. And what is your competitive advantage?
I would say our competitive advantage is the capacity to do both. To cater to both regulated setups and do verifications directly based on verifiable credentials in those cases where companies actually need to store the data, conduct additional screenings. So that can be achieved with our tool. But we can also do, as we showed, privacy-preserving workflows. And our added advantage is the capacity to enable these two types of workflows with the same tool from the same dashboard. And there are many companies who are running both types of operations, and they would like to run one type of workflows on one of their part of their products, and another type of verification that is more based on gathering data on another part of their product. So now they can do everything in a single place.
Wonderful. Thanks for clarifying. We have room for one more question. We got one from Michael from Aurora. Privacy and compliance feels like a misleading pitch when the regulated example from your demo still has the user's information. Will there be an option in the future for regulated companies to use flows similar to the DeFi part of the demo?
Yes, it will be possible. It's something that we're working on. So we show two extremes, like one for regulated companies who actually need to control the whole access to the data. Then we showed the extremes with zero-knowledge proofs, but we're working on a middle ground where a company that is still regulated can conduct a flow that is similar more to the ZKP1. Yes.
Oh, that's great to hear. We're also out of time, so Bogdan, thank you so much for being with us, and looking forward to catch up again.
Thank you very much.
Our pleasure.
Bye.
Goodbye. All right, so that were our showcasing stars of today, and we will be moving within a few seconds to our panel discussion centered around the topic, the state and potential of zero-knowledge proofs. For the people that don't know much about zero-knowledge yet, it's a form of cryptography, and it has been actually around for decades in academia. However, last few years, it's transitioning actually into the industry, and we have today a big pleasure to actually obtain first-hand invaluable insights from remarkable ZK luminaries and experts that are shaping the industry as we speak now and setting a new standard based on privacy and security. So, dear panel speakers, get ready as I'm about to bring you on the stage. Yes. Welcome all. A pleasure to have you on, guys. Yeah, let's start with a little introduction. We can start from Leo and move from top to down. So please, Leo, give us a little introduction about you, your company, and its mission, of course.
My name is Leo Fan. I'm a co-founder of SASIC. So at SASIC, we do hardware acceleration for ZK. So we try to make ZK proof generation in real time, which means like the proof generation for almost like all this like ZK circuit can be done in like 1 to 2 seconds. So that's our goal. Yeah.
Awesome. Thank you so much. Florian Kluge, please.
Awesome. Thank you for having me. So yeah, I'm Florian. I do engineering at O1 Labs. To give you a bit of a background story, O1 Labs, we originally incubated Mina protocol, and we are also still actively working on Mina protocol. Besides that, we are working on O1JS, which is a TypeScript framework for writing zero-knowledge proofs and smart contracts on the Mina chain. So we are essentially trying to make ZK proofs accessible by the audience outside of academia and like hardcore blockchain and protocol people. So yeah, we are working on that. We are also actively working on the big Mina upgrade, which will eventually, hopefully very soon, bring zero-knowledge smart contract ZK app to a production-ready network. So yeah, happy to be here. Thank you.
Thank you for the brief introduction, and a big pleasure to have you on, Joanna. Please give us a little introduction about yourself.
Sure. Thank you for having me here. My name is Joanna. I work at Alio. I'm the head of BD there. And Alio is a L1 blockchain. We're the first fully integrated privacy-preserving quality focused blockchain, using zero-knowledge proof as the key technology. As you mentioned, this technology has been around for a while, and our founders actually were the ones that, and advisors were the one that came up with Zcash and Zaxseed, which is a zero-knowledge execution white paper that kind of kick off the whole programmable privacy movement. So really just been on this journey for a while and ready to get ready for the mainnet launch this year.
Wonderful. Let's go. Anish, please give us a little introduction about you.
Hi there. My name is Anish Mohammed. I am a co-founder, CTO, and the chief scientist for Panther Protocol. Panther Protocol, we provide privacy for DeFi, compliant privacy for DeFi. So we've been around for the last 4 years. That's what I would summarize.
Many thanks. Welcome, Nilufer. Please share us a little bit about you.
Hello, everyone. I'm Nilufer, protocol researcher from Gavolot. At Gavolot, we are building the first decentralized proving layer designed for the modular stack. And our mission is to reduce the cost of proving, and we achieve this by aggregating proving workloads from across the industry, across all use cases. And this allows provers to better utilize their hardware for maximum cost efficiency. Thank you for having me here. It's so exciting.
Our pleasure. Alexander, a big pleasure to have you on too. Please share a little bit about you.
Yeah, hi everyone. My name is Alexander, and I'm CTO at Polygon ID. And we are building a self-sovereign identity protocol and set of tools on top of it, and a whole ecosystem of issuers, verifiers, and of course wallets for the users to use our identity solution. And we are leveraging power of zero-knowledge proofs to essentially improve users' privacy for the data, so that users would be able to prove that they are over 18, or they are not from a country or from a blacklist one, or let's say it's possible to do other very interesting things like build trusted on-chain trustless decentralized issuers, so that there would be no need in trust in some centralized party to verify that this issuer is performing correctly his job of issuing credentials. So very interesting different use cases that we build right now, and hope to bring to you as soon as possible.
Let's go. Thank you so much. We got also another ZK hardware heavyweight here. Emmanuel, please.
Hey everyone, my name is Emmanuel. I do product at Ingoniama. We are a semiconductor company. We're developing acceleration products for cryptography, for ZK, for FHE. Yes.
Wonderful. And last but not least, Alessio, please.
Hello, and thank you for having me here. So I'm Alessio, Head of Acceleration Program and Ecosystem Manager at Manta Network. So our ecosystem includes Manta Atlantic, our L1 solution built on top of Polkadot, and then Manta Pacific, our L2 that utilizes a Celestia data availability layer. You have experienced very rapid growth as one of the fastest growing L2 in the space, boosting over 2.5 billion in TVL and more than 220 projects that have been deployed on our platform so far. So at Manta, we are shaping a secure and interoperable future with zero knowledge. And our goal is to provide the best experience to developers for ZK applications.
Thanks so much for the introduction. It's wonderful to have all these ZK big brains among us. So let's start our panel discussion with my first question to you. What are, in your view, the main value proposals from ZK, and what type of innovative use cases does it enable for applications? Yeah, feel free to open your mic and tap into it, anyone.
Maybe I can jump into a couple of thoughts here. I mean, ZK has been a technology, has been around for a while, but really recently found this product market fit, I would say, in two areas, right? One, scalability, one is privacy. And that's, I think, why everybody on this panel is here building on. And it's still considered as a nascent technology, but as you can hear from today's demo, right, a lot of pitches are focusing on some of the use cases that I think we are seeing a lot of traction in, such as identity, when it comes to the privacy camp, right? So we see, like, on the high level, on the protocol level, I would say, because I represent a protocol, there's the big divide, right, on the rollups who are focusing on the scalability side, and the L1, which we came from, that build our own virtual machine and our own kind of a tech stack from the ground up to enable privacy. So yeah, again, on the innovative use case, I think from the privacy side, we've seen a lot of like interesting privacy-enabled games and asymmetric games, that kind of we all come to love in our real life, and also on the DeFi side on some of these dark pool applications that doesn't reveal your competitive edge when you do trading, but identity is a personal favorite on the privacy side.
Wonderful. Anyone else?
Yeah, I'll give it a go. So just so that I give a historical perspective, probably I'm one of the people that have been in this space pretty long. So my view is like the real paradigm shift that's actually brought, that really actually changed this game is soundness and completeness. And in that sense, that when used in a non-interactive sense, it's changed the game. So as somebody who was there when the first of the papers were published, the real paradigm shift was, okay, until now we could actually do a bunch of things like quadratic reciprocity and things like that. Now we have this mechanism where we could do something realistic. And until then, if you wanted to have authentication, you actually needed to share something. And this paradigm was broken by zero knowledge in that sense. And in the sense, like, you could actually do a non-interactive mechanism by which you don't have to share a known secret and still authenticate. And that then opened up to this possibility of having identities, privacy, and things of that sort. And on the side, what has actually happened is, like, given you could actually do this non-interactive bit, you could actually bundle up things. And that became this whole construct of, what we see as rollups, right? And again, this is a question that's quite open, and there's a trade-off that's there. If you are really optimistic, you could actually go, I really don't have to validate the math, and I could just assume that people are going to be fair, and if I toss a coin, I'll get a result X number of times. That's one edge of the thing. And the other edge of the thing is like this construct where the whole of the society is suffering from information arbitrage, or as some would describe this as a surveillance economy. Zero knowledge actually really allows people to actually have a construct of being able to do validation interaction with credit service, whatever. This whole bundle of things we normally interact with in a normal financial system, with some sense of privacy where this whole machine learning paradigm is not converting you into a lemon. I mean, it's an inverted lemon market. You yourself becomes a lemon. So that to me is an interesting construct, and there are a whole bunch of projects, products, and protocols, including us, right? Like, which are trying to do this, like try reduce this information arbitrage and reduce this exposure of an average person. This is very much because of the paradigm and openness of L1s and L2s. So that's what I would say.
Thanks for elaborating. I want also to challenge everybody. Feel free to tap into each other's thoughts, and definitely feel free to elaborate on what do you think are the main value proposals of ZK and its use cases. Perhaps Emmanuel?
Yeah, so I think one of the main values really is also like lots of information that people they provide to banks, like credit cards, KYC. Even today, when it comes to like AI, when you're sending your information over to different companies, you basically have no control over this data once it's sent over. And I think ZK really can help customers protect their data and not limit the services which they can enjoy. So you can send your, like, even when you just go to rent a car, you have to give your credit card details, right? And someone can just steal that. So I think this is the like privacy and the scalability, I think, are really the key points. Yeah, that's my take on it.
Thanks so much. Alexander, perhaps?
Yeah, I wanted to share some ideas on use cases related to identity. First of all, I think voting and this kind of use cases on funding and voting is very interesting ones, and ZK is enabling doing this in proper way. I mean, with privacy in mind and security also. Yeah, then we have a lot of different use cases where no one is still working, but I think there is a very big potential in fighting bots, fighting misinformation, fighting propaganda, and I think zero knowledge proofs can prove your identity, that you are not a bot, and you would be able to use your platforms more or less in invisible way, but a platform would protect itself from bots, from masses of fake comments and so on, or fake reviews. Yeah, so this is something that I think we can achieve pretty soon. But then there is very interesting use case on research, on scientific research, where we have a lot of data, like medical one, but it's in silos, it's in different hospitals, it's on users devices, but it's not shared. And researchers right now have problems, so that they need to get this data from a few sources, centralized ones, or then how do you source from all around the world? So it's very hard, and especially hard to do it properly without leaking data about users. So just because it's medical data, it's very sensitive. You don't want to share just all of your data, and even some pieces that could be very sensitive. And then if you imagine it as a researcher running ZK program on a user side in a kind of identity wallet that would have control, over users' data and have access to it, and then data would be provenly verifiably coming from trusted sources, so it would not be fake ones. And then, yeah, only result of this evaluation would be returned to a researcher. So I think it's very powerful.
Thank you. And a short question to you, Alexander, regarding ID. Do you think AI approvability against, for example, deepfakes can be tackled by zero-knowledge proofs?
To some degree, maybe, just because, yeah, if you, let's say, have a government issued document on your device in your wallet, then you would be able to prove that you're not a bot, that you have a possession of this document really, and then some additional checks maybe would be required to just check that you not only possess this document, but you are really this person who is on this document. Let's say by running zkML, that would be verifying that photo in a passport matches to the picture on the camera, and then sending this proof somewhere. Yeah.
Thank you
So
for
you mind
elaborating.
if I agree to
Please.
disagree with the previous speaker? I mean, I just wanted to be sure that I say what I know. I'm a medical doctor. I've actually got a degree in medicine and licensed to practice. Then I went to grad school to do cryptography, and I worked on all these things, privacy preserving machine learning. You can Google and find out. So one of the biggest concerns that I have when people talk about ZK is they conflate two things, right? Privacy set has nothing to do with ZK. When you have a large enough privacy set, you can get probabilistic privacy, right? And a lot of the assumptions that we make are completely wrong. And the reason I want to put my hand up and say this is like, we are very technical people. When people listen to us, they take, given we are considered technical people, when we say things that are not to the degree correct in that sense, right? You can only imagine what happens with other people, right? Just think this through. I can talk about both the things that we had just discussed recently. I just wanted to give you like a very simple sense of the challenges in privacy for healthcare data. I just described at the very high level the information arbitrage. That is the biggest challenge. And if you ever think that all the big pharmaceutical companies don't have data on all of us, we are all idiots, absolute utter idiots, right? This is massive information arbitrage. The question here is like, how can we actually leverage, add value out of having different techniques we have in machine learning models, right? So there was this thing called translational bioinformatics, where you actually look at drugs and you look at the comparison of like how genomics get activated and how drugs that have compatible profiles and do drug discovery. Similarly, you could actually analyze like adverse drug reactions. When somebody's given some drugs, how does this interact with people and things like that. All of this, while ZK could actually add some value, it might require other techniques, right? ZK will be one of the tools that's available to us in addition to FHGs, MPCs, I don't know, like every tool on the box, right? And the key of the thing that we need to recognize is like the cost of actually doing all of this has to be in line with the value we achieve. If the cost of doing a ZK becomes so high, that's of no interest. And like the simplest of the narrative I normally describe is like people going to McDonald's and having smoothie. I don't believe anybody would actually go to McDonald's to have a smoothie. You're very likely to go to have a burger. That is the key construct we all, as people who do ZK, should recognize. We really can actually add value, but we need to really recognize what the trade-offs are and what we can actually do. Like we making bold claims. The reason I say this is like when we say things publicly, a lot of the people in this audience include people who are so-called the decision makers in the larger context, right? They get informed by what we say, right? And once they have some ideas into their head, then that's the basis for them to go talk to everybody else. And by the time we wake up, this narrative has already left, right? So we have to be mindful and kind of frame it in a sense like, this is what it is. And talking about verification of things, there's actually a researcher who actually works with Dan Bonney in Stanford. She published a paper which kind of describes some of the ZK mechanisms by which you could do verification. And one of the challenges you typically have is like, unless you have some computation or secure computation element in most of the phones or the cameras, most cameras actually do have them, it'll be very hard to tie everything together. Okay, I'll keep my mouth shut.
That was awesome. Thank you. Please, Emmanuel.
I also think that like ZK doesn't necessarily solve like the entire stack, right? So for example, when people speak about like, let's say, privacy and scalability, ZK won't let you, let's say, compute on encrypted customer data, right? So you need FHE for doing something like that. What ZK would let you do is, let's say, prove, like a client could prove that he verified something in his medical records correctly. So then, he won't have to expose like unnecessary data to some, let's say, private doctor office, right? So let's say that he has like data inside the government hospital, and then he goes to some private doctor. He doesn't want to expose all his records, let's say, and make up some theoretical situation, right? Then he can compute on his own data, let's say, and generate a proof just to verify to this doctor something. So you don't necessarily, ZK won't let customers hide all their data from everyone. It just lets them run some computation one time, so other people don't need to run it. And it lets them hide certain parts of that data, right? So like with like ZK ML, for example, you can like prove that you ran some private neural network on some public data, right? But you can't, let's say, send private data to some third party to actually compute it, right? So yeah, I think that's maybe that contributed.
Oh, absolutely. Thank you so much. And I got to say, there have been already quite some mindsets shared. So I guess there's a lot of alignment here. But if there are other speakers that haven't spoke yet and have an idea, please share it.
Yeah, I would like to bring up a couple of other, key value propositions of the ZK proofs. So it could be, for example, for the auditability. So the ZK proofs, allow individuals to demonstrate the accuracy of calculations without disclosing sensitive details, right? So that will enable building system where parties can prove, the reliability of their data and operations to, for example, independent auditors or, these kind of entities. And at the meantime, this will ensure transparency and accountability. And it could be used in several industries like finance, where trust and integrity are crucial. And then another key value proposition of the ZK proofs could be the interoperability. So the ZK proofs enable communication between different blockchains, but also between blockchains and traditional systems, even if they use different protocols. And ZK is, ensure that sensitive information remains private during these exchanges of information, allowing for, secure transactions and interaction without disclosing all the unnecessary data. So I think that these two key value propositions are also worth to be mentioned for the ZK.
Yeah, thanks for sharing your scope. If anybody wants to tap in it, please, Florian.
Yeah, I can just highlight a couple of things that we already talked about, but I want to give it a bit of a different point of view, so to speak. There's pretty much two value propositions that I see at the moment. Number one being scaling. However, scaling at this point is something that we know how to do, more or less, and it has become more of an engineering problem and less of a sort of like research, innovative type of thing. The second one being giving people integrity and giving them access to their identity. And that includes the entire aspect of having KYC, proving identity, also giving them more integrity over their medical data. I have no background in medicine, whatever, but it's similar, right? Giving people integrity over who they are, and what they are doing, and that is still a not really solved problem. Many people also don't think about the process of getting data. Like, where do you get data from? Many people just take arbitrary data and make a CK statement about that. Then they have proof of it, the proof of computation, but the data is still like, you don't know where the data came from. You still need a trusted data source, especially when it's like private data. There's a big company has data maybe, and you want to do data over encrypted data, computations over encrypted data, you do need other aspects of computation and cryptography, like FHE and stuff like that. So there's a very big problem space of things we haven't even really considered. There's scaling, and we sort of like know how to do it. There's still open questions, but it has become an engineering problem rather than a scientific sort of like, we really need to get this done now. There's many projects doing scaling, and they're very good at that, but there's not a lot of projects really solving the integrity and identity crisis of users, and that's a big thing, and I hope people will start solving these problems.
I'm looking forward to that too. Fortunately, we have Ingo and Yama and Saisek that help or are on a mission to empower the computing power. And yeah.
Yeah. So let me add a little bit more thoughts to the problem, like the concept of the case. So like so for here I would like to borrow some since like my background is like in academia, so I would like to borrow some comments from Silver and Bicani, who together with others like invented the ZK concept. So he mentioned like so like we all know like encryption. So encryption is like you encrypt some data, then you cannot see like what's inside the ciphertext. So for here ZK so like ZK has the same functionality for computation. So like you encrypt the computation. Like for instance, like I want to convince you like 3 + 5 = 8, but I just convince you this fact holds without telling you anything specific about this computation. So that's how ZK goes. But if we want something more such as like succinct, like we can have this like succinct less from ZK. So that's another property, and people are like quite happy with that less property.
Thank you so much for sharing your thoughts. Perhaps Nilüfer, do you have something to share also, or has everything already been shot?
I agree. I think any use cases that protect sensitive personal data and that allows individuals to have control over their own data is really exciting and empowering.
Absolutely. I strongly believe so too. And I have another question to ask. We have seen today a lot of use cases that are enabled through zero-knowledge proofs. And I have the feeling that currently the Web 2 world is quite unexplored with ZK use cases. Do you have any thoughts? What type of Web 2 industry sectors could significantly benefit from zero-knowledge technology?
Yeah, so I'm actually pretty excited about like KYC, and because I'll explain like how I'm thinking about it. So today, when you go into any website or you send an email, everything's encrypted, right? So they encrypt all of your data. But when like different banks operate, and even globally, let's say a bank in Cameroon is speaking with a bank inside the US, right? There are standards of communication, but I think with the developments in FHE and with ZK, and then advancements inside hardware, you could have like some type of like data sharing protocol, where different institutions can communicate with each other, and they'll have some sort of level of trust that they're really computing on like accurate data, and also that some like standard is being executed. So like if like someone sends KYC documents from a country that isn't really digitized, like how do you know that that's actual real like KYC from a real bank? And this is, I think, a huge problem with many like financial institutions.
I hope you don't mind if I say a couple of things. So there's this construct called passporting. I gather most of you are not used to retail banking. Again, somebody being old who worked for various banks. Last I worked for HSBC before I left. So we had this construct of passporting. So if you were to come to Europe, at one point in time, UK would allow passporting, your KYC would be done, and then your money is available for all this mechanism. Yes, I completely agree with the previous speaker. If there was such a thing, that our regulators, so FCA in the UK, right? In fact, you have to give credit to FCA for what it's worth. They actually had an incubator on NPCs just before COVID, and the last cohort came out. I don't know if there was any of those got into the FCA list of accredited KYC, KYT providers, right? So absolutely, there's a whole chunk of use cases in the Web2 world, starting with passwords. Just start with that, right? Then there's all this credit agencies. That's the next one, right? In the banking conversations are much more harder because of the regulatory arbitrage. What I mean by regulatory arbitrage is like different regulatory regions might have different requirements. So if you are a US citizen, the requirement that you have is very different if you are a citizen of UAE or if you are a citizen of Vanuatu, right? So there are things we could do, but in general, the question of authentication with multi-factor or whatever it is, and all those data that's associated with that kind of transactions, historical financial transactions or things of that sort, absolutely could go away and be used in ZK. So I completely agree with the previous speaker on that bit.
Yeah, thanks so much for sharing. I gotta say, I'm not that big of a big brain in ZK, but I have a chemical engineering background, and I know a lot of oil companies, they cooperate together on projects, yet they are very careful with sharing sensitive information, for example, about supply chain routes. And I do believe that zero-knowledge proofs could significantly help to make sure that not too valuable data leaks or gets in the wrong hands. So you can only provide the relevant data and more efficiently and trust work together. So yeah, that's my little 2 cents on that topic. And if anyone else has something more to bring on the table, please.
Yeah, I do. And I guess that's also maybe an open question to the rest of the panelists. So just to get started, there's many use cases that we also just talked about where I feel like ZK can be very powerful in Web 2. However, big exclamation mark, I feel like the culture and other things between Web 2 and Web 3, they're just too different to really put ZK to the use in Web 2 today. And I feel like there needs to be a lot of work done in order to give Web 2 enough trust in Web 3 technology. And that does include the advancements that we do in ZK, be it research advancements or also tooling advancements. And from my experience, when talking to people from the Web 2 world, they're still a bit hesitant to really rely on this magical concept. They would rather go ahead, simply integrate their existing product with an API and like a big company they trust, right? Like, why should they replace the channel in between if they do trust the other company? There's no real need for them. Additionally, I also feel like, and again, that's an open question, I'm curious what other people feel. Users also don't necessarily feel the same need as we do in Web3. If they sign up somewhere, they will use Google single sign-on solutions because it's convenient. If you ask them, do you want to sign in with a CK enhanced login solution or whatever, or do you want to give me your data for an exchange of a small, I don't know, 5% off of your next purchase? What will they go for, I guess, right? So I would guess that there's not enough trust in that type of stuff and not enough need for normal users yet. But I'm curious to hear what other people think about that.
Yeah, I probably would put my hand up and say something. So NIST, I'm sure you're all aware of NIST. So I don't know if any of you were there at ZK Proof in Washington, D.C. and now October 30th or November 30th, November 30th, I think. So there was Rene Penalta from NIST in the program, and he was giving a talk. And if you were looking at NIST, and I'm sure everybody's aware of NIST, right? So NIST is this body in the US who typically, produces lists. So AES is a standard that came out of NIST. NIST as always has this list. There's QC resistant algorithms, FHE algorithms, like different sets of algorithms normally comes out of NIST. You could almost think of NIST as having some strange relationship with NSA being the cryptanalytical arm, and NIST being the public arm in that sense. They literally produce a whole bunch of guidance. It's like pretty much guides everything else. So if you are there to look at FIPS and like a whole bunch of other ones, so FIPS is like a bunch of standards that are available for financial, key management and other things in financial regulation. So my take is like, it takes two sets of things or three sets of things to happen, right? One is there has to be some standards that need to be agreed as being adopted. If there is no such standards, there's no way that anybody could look at anything. Secondly, the fact is like, once there's enough of, standardized things available. So what, just as somebody who's actually sat on ISO committees and things like that, whenever we have a normal crypto algorithm, full disclosure, I put my hand up. AES CBC mode test vector. That's my task. My PhD supervisor asked me to do that. I did that. So whenever you have a mode, you produce a test vector. We haven't reached that level of maturity, right? ZK hasn't reached that level of maturity where we go, these are the curves, these are the schemes, these are the test vectors, these are libraries. You use this, you should get this, right? And you don't need to know anything else. I mean, that's the level of maturity that we need to get. So we, other people from outside, I fully agree with the previous speaker, which is like, they are not seeing benefits of actually having to learn some abstract random algebra and a bunch of elliptic curves, which is really boring for anybody who's not that interested. Is really, really, truly boring, right? Why would they go learn all this stuff? They have no incentive. So, unless there has to be a regulatory change, where the regulators of the world recognize that this in a nation state level, there's an information arbitrage that exists. If there are two states, one has privacy and one that doesn't have privacy. If there was a war between one state and the other state, like nation state, peer-to-peer war in that sense, the nation state that actually doesn't have any privacy, the nation state that has privacy, they don't really acquire a lot of intelligence gathering. Like if they put a bomb over there, I'm just suggesting people should bomb, but they could just look at the public data, right? Just look at the public data and figure out, okay, this is what has happened. So as a nation state, they should be incentivized to understand that privacy adds value, and zero-knowledge tool systems and tool chain and standards could add value. Having mechanisms of authenticating, having ID, national IDs and other things with ZK adds value. But unfortunately, politicians are, at least in my mind, I could be completely wrong, not the smartest of the people in the world. And they are not, even if they are smart, they're absolutely not incentivized to do the right thing. So, when you combine both, we have a tricky situation. So my 2 cents is like, if we get any chance in doing that advocacy, where we try to explain to people, we should definitely try our best. We should try make this barrier to entry lower. Try help people, offer them help if you can, so that there are more people in the web too that understand this and they're interested in this, and they they really are the ambassadors of ZK rather than us. That's what I would say.
Yeah, so for here, like I would add, I totally agree with the previous what the previous speaker said. Yeah, so like previously, like I work a little bit at NIST doing some evaluation on the post-quantum crypto systems. Yeah, so like there is like a non-procedure for NIST to like put their effort to evaluate something. Like, yeah, but if there is some like urgent, such as like in the past 2 to 3 years, or like maybe like 3 to 4 years, there is like a trend to use thresholds signatures in different parts of like blockchain. So like NIST starts to put their effort to have some seminars like to try to evaluate like different approach to do the threshold signature. And I think like probably like they will also, as like ZK like is becoming like more and more important in the blockchain and other communities, so probably like needs to also start to like evaluate this kind of stuff.
I'll keep my comment short so other panelists can chime in as well, but I want to concur what Florian said earlier. The culture between Web 2 and Web 3 are just really, very different as of now. So the main thing, like to respond to your question, right? What are people doing within the ZK space? Like, how do we get this Web 2 players to come in and listen, right? So one thing I think what we do at Alio from a protocol level, so we have a product team that come up with a first party dApp, right? So we come up with this like first variation of the experiment, and then it's called ZPass, right? So it's a attestation layer that's sitting on top of any existing KYC infrastructure. So with that kind of application, then we go to these Web 2 players and say, hey, whatever, like PayPal or Visa, right? The payment processors, you don't have to build your dApp, your application on top of the protocol Alio here. You just have to plug your API into this attestation layer that helps you to not reveal your consumer data, right? Protect the privacy of your consumers in compliance with all the regulations, but also providing this like very elegant solution where you can quickly verify the credentials, right? So I think that's like one way to really help these Web 2 players to start to realize the benefit of this, having a technology player on their as their advisor, as their partner, right? Tackling the solutions that they haven't been able to solve. But at the same time, it's like not drastically or radically change the existing infrastructure they come to rely on. So like one example is we're actually partnering with a company called Common Sense Media. So they do these age verification for school-age children for the Department of Education in the US to, basically help out with like safe internet surfing. And we just become the technology partner for them so they can help us kind of broker all the relationship that we're not really familiar with, but all we do is to provide the technology at the back end. The user doesn't even have to know. So I'll leave it there.
Wonderful. Thanks so much for sharing. I wasn't aware of ZPass yet. That's amazing. And if someone else wants to tap into it, please.
Yeah, I would like to add that actually we may see big changes on the market coming from governments themselves. I mean, already a few smaller countries are looking into ZK Tech and rolling ZK-based identity systems. So I think it's coming, and it's just a matter of time when all the kind of industry will align and come together with solutions that would work and solve real problems, because governments have problems, and identity is a big challenge. It's very hard to handle properly. So that's why GDPR is there, right? And governments want to protect their citizen data. So yeah.
Wonderful. Then I have to share, our schedule got a little bit delayed, and I can imagine that you are very busy and have important tasks. Like, I'm having truly a wonderful time to have you on board today. Is it okay with you to proceed a little bit longer? And if you really have to go, it's okay. So I just wanted to share that. I was wondering.
I
Sorry,
probably will have
please.
to drop off. Apologies. I'll have to drop off. I'm running a bit behind. Thank you all very much. Thank you again for the opportunity to talk to all of you.
Our pleasure,
It's real.
Anish.
Okay.
Of
take care.
course. Have a good one. So I will skip one topic, and actually one topic that's more for Saisek and Ngonyama. what do you think about ZK hardware? How does it empower the future of zero-knowledge proofs and builders in the process to create ZK applications? And in addition, if others have also thoughts, please step into it.
Yeah, so I think that the role of ZK hardware is extremely integral to the success of cryptography in general. Because when you're looking at all these emerging techniques such as ZK, FHE, like even 5 years ago, they were extremely slow. Like you couldn't use them for anything. FHE is still very, very, very slow. Like it's not really practical yet, right? But I think building hardware and aligning it with the software and with the algorithms is the key to making this technology something that everyone can use. And currently also, I think that for developers developing and building these protocols, performance is very, very important, and how much power your hardware actually uses. And before these companies like Ingonyama arrived, there was really a lack of tooling to actually build ZK protocols. So, for example, one of our key products is Icicle. And Icicle is a GPU library for accelerated ZK. So it's basically a toolkit where you as a protocol developer can come and build your ZK protocol using Icicle. And this protocol will now scale to the data center level. So you can now run this prover on your GPU at home or in a massive data center with hundreds and thousands of GPUs. This last point about GPUs, I think also there's like a ladder of for example, I don't think that we're going to see, let's say, the best ASIC come out anytime soon, right? I think it's going to be like slow development until you're going to have dedicated chips. So I think if you look at like Bitcoin mining, right? For example, where it went from like CPU mining to GPU to like some versions of ASICs, and now if you want to do Bitcoin mining, you use ASICs, right? So I think also if you compare it to AI, it's the same sort of progress. Yeah.
Thank you so much. Absolutely, Leo.
Yeah, so I totally agree with what Emmanuel said. Yeah, so I would just add a few things here. So yeah, as we know, there are several ways. Maybe there are the current drawbacks of ZK. One of them is the ZK proof generation is quite slow. Yeah, so we have an internal GPU CUDA code who we try to optimize a lot, but we still couldn't achieve optimal. By optimal I mean the real-time ZK proving. Yeah, so so there are two things. The one thing is to say how can we reduce the proof generation time for ZK, and second is to say how we can make the other ZK projects they use our hardware. So we don't want to do some tailor-made software hardware integration for each project. So that would be two human power intensive work. Yeah. So for the first thing, to achieve a higher proof generation speed, we need to do this end-to-end proof acceleration. So we are not just accelerating the previous major kernels such as MSNTT. We also need to accelerate the previous fluffy kernels. We need to make every possible components in the ZK proof generation faster. Yeah, so we are architecting ZPrice this year. So ZPrice is a community effort to accelerate the ZK. We were just architecting one track of ZPrice. Yeah, it's using hardware to accelerate ZKP. The first part is to say we just accelerated one component, the multi-scalar multiplication, and second one, the one that will start in April, is to say we want to achieve end-to-end proof acceleration for ZKP. And in addition to that, we also need to care about the environment, the ZK proving cost, things as more layer 2s, more other ZK project, and also the privacy-oriented layer 1 protocols such as ADO come into the the market, we could see a lot of demand in the ZK computation. So like we architect the price to make sure that the developers, the hardware developers, also pay attention to the energy cost, to the energy consumed by the ZK proof generation. Yeah, so that's for the first part. And for the second part, so like we want to make a hardware that is like easy for people to use. So it's like a plug and play. So you don't need to customize the code to like switch the part. Like you can accelerate on your GPU or some other devices. Like you need to do a lot of like customization for each project. We want to avoid that, and we have already found a solution to avoid this project to project customization. Yeah, so it will make people like to use our hardware like more friendly way. Yeah.
Awesome.
I'll add just one more thing. What Leo said also was like very good, and I just wanted to add like one more thought. So like besides okay, so like right now I think the like state of things is that we're seeing all of these libraries like Icicle come out to help people integrate acceleration and build these protocols. But I think also one of the interesting things is that like as these protocols start using this very like these different libraries, things are like going to change because for example, as like Alio starts integrating, let's say, acceleration maybe into their protocol, miners will need more and more and more optimized systems. So like it's not just about accelerating MSM and NTT, like Leo said. It's also about like doing the like entire end-to-end proving, which also in the future you're going to see like more and more advanced libraries where for example you're going to be able to like split MSM across multiple GPUs, and you're going to need to interconnect these GPUs to like optimize data read and write from the actual devices, because one of the largest bottlenecks actually is the latency of copying data into device, right? So you're gonna see like these. So I think over the like next year, 2 years, you're gonna see more and more and more complex proving operations with more and more optimizations, not only on the software level, but also like actual on the hardware level. Like how do these proving servers look, and how are they actually deployed? So I think like slowly, it's going to become a very complex operation of hardware, software, data center design, stuff like that. Yeah. And protocols, I think, play a really important role in this, because I think they're really going to drive the actual demand for performance, for lower power consumption, faster proving times. So I think like as we see more and more protocols come on, and more miners running these actual protocols, you're going to see like acceleration and I guess like proving performance.
Let's make it happen. Is there any hardware maxi or wizard that wants to add something more?
Yeah, I would like to add a little bit from a different dimension. My thoughts on this ZK hardware works well and serves well scaling purposes, but not really privacy, because for privacy purposes, you want your data stay on your device, and that would be could be low-end phones, So we actually, what we need from the other side is optimization of proving schemas, of algorithms to work on lower-end devices, and to be able to generate complicated proofs on your phones, on regular ones, so that in this national ID use cases, it would be possible for a granny to use her very old phone and still be able to generate zero-knowledge proofs.
Yeah, so like we are thinking about like coming up with some like hardware such as Ledger, like who can generate ZK proof on your web backend. Yeah, but yeah, so that's something possible we can do. Like since like for this like privacy oriented ZK circuit, they are like usually quite small, and yeah, so like for like very small circuits, you can always use your laptop to generate the ZK proof. But there are some like your case where you don't have a laptop or your phone is not powerful enough. So like maybe we can have some like devices that have like in a similar form as like Ledger who can connect your phone using a USB-C port to communicate with your phone to do the proof generation. So that's something like we can do, and it all depends on the demand. If there is a huge demand in that part, we can of course come up with some like no power devices that can do such a job.
One also I think interesting, so this issue, like, okay, so client-side proving is a very serious issue, I think, because not everyone has a big GPU sitting on their machine, right? And like, for example, even one of my friends who's developing this ZK app, when it runs on desktop, it proves in a couple seconds on the powerful Mac CPU, right? But when it runs in the browser, it takes like, I think, over a minute, right? So one interesting feature of NVIDIA GPUs actually is they have this confidential compute where you're actually able to send over data to like a data center, and then it's like sort of like a private enclave on the GPU itself, which can let you basically like generate this proof, and the like data center won't be exposed to your inputs. But yeah, I think there definitely has to also be some advancements in client-side proving. Maybe it will come from like let's say like M1 Max have a pretty powerful small GPU inside them, but I'm not like there have been some like I guess like progress in this area, but nothing very significant yet.
Yeah, absolutely. And I would love also to ask Alicio and Nulifar a question. What do you think are the current bottlenecks centered around zero-knowledge proofs, and what may be needed to make the ZK technology go mainstream?
I think the current bottlenecks are the proving cost and also speed, as other panelists mentioned. And so we need optimized hardware, also flexible hardware that are more standardized so that it can interoperate between different ZK applications. And also that will lower the barriers for entry for developers looking to generate zero-knowledge proofs.
Wonderful. And Alicia, do you have any thoughts?
Yeah, I would like to say a couple of things before I have to drop off. I think that there are several current bottlenecks that need to be addressed to make the ZK technology mainstream. So first of all, the complexity and the lack of standardization. So the ZK proofs, often involve complex cryptographic protocols and mathematical concepts, making them, a little bit challenging to understand and implement for developers without specialized expertise. And in addition to that, there is also a lack of standardized frameworks and libraries for building, the ZK applications. And this leads to fragmentation and interoperability issues, across different implementations. And then second of all, I would like to mention that ZK proofs typically require significant computational resourcing, including, for example, both CPU and memory for generating and verifying all the proofs. And this high computational overhead can limit, the scalability of these applications, in particular, in resource-constrained environments, such as mobile devices or IoT devices. So I think that, while ZKPs offer scalability benefits compared to traditional cryptographic techniques, I think that there are still limitations in terms of, the size and complexity of the computations that can be performed by using, existing ZK protocols. So I think that should be it on my side. I just want to thank you for inviting me. I just have to drop off, as I said.
Yeah.
So thank you very much. And
Our pleasure. One question
Have a
before
nice-
you go. How
Yeah.
can our beloved audience find more about Manta? And is there perhaps anything they can get involved with? For example, a hackathon, an ambassador program, or a community-driven hub?
Yeah, so we have a lot of initiatives at Manta. So for developers, we have some hackathons. So we will announce them from time to time on our social media channels. You guys can join us on Twitter and on Discord. And then we also have several initiatives for startups. So we have the grant program, and then we have an acceleration program, which is basically, an initiative that we decided to launch just a couple of months ago, where we want to, enhance the visibility of the startups into our ecosystem and push them toward our ecosystem. We want to help them, raising funds and be connected with few dedicated mentors in the Web3 space. So I think that, chances are endless. So whoever is interested in, being involved in our ecosystem can just contact me or, someone at Manta Network. We would be more than happy to work with everyone. So I think that should be it.
Well, you heard it, folks. Thank you, Alicia. Have a
Thank
great
you.
one. Yes. So if anyone has something to tap into the previous question, please go ahead. If not, I also want to slowly wrap up our panel discussion and want to ask the same question to all of you. How can our audience, which consists out of developers, Web3 users, researchers, can get involved with your company in any way?
Yeah, so Ingonyama, okay, so I think there's a couple ways to get involved with Ingonyama. One is we have a library named Icicle, which, as the fellow from Manta said, everyone's lacking a standard for ZK acceleration. I think Icicle really serves as a very nice standard for heavily optimized primitives for ZK. So if you're a protocol developer and you want to accelerate your protocol, you can come have a look at Icicle. If you're a researcher or a developer, you can come, implement support for a new curve, optimize Icicle, take part in the development. We also have a grants program where we will fund research. So anyone that's interested in doing some very interesting research into ZK or write software, basically, if you're looking to build or research in ZK and you have an interesting project, you can come and apply. I don't know where to drop a link, but you guys can reach out to me on Twitter, I think. Yeah. And then we also have a Discord. The Discord has a lot of people asking interesting questions. Yeah, and everything that we do at Ingonyama is open source. So you can go and have a look at any of our repositories, reach out to me, be like, hey, I'm interested in this repository, and I'll help you find something to do, I guess. Yeah.
Oh, you heard it, folks.
It's actually a very good way to get hired at Ingonyama as well. If you do something very cool, we'll offer you a job.
Oh, that's interesting to hear. Thank you for elaborating on it. It's ingonyama.com, folks, so definitely check it out. Thank you so much, Emmanuel.
No problem.
And let's go from top to down. Leo, please, could you please tell me how our audience can get involved with you?
I see. Yeah. Okay. Yeah. So SciSig is working on hardware, as you know, designing some chips, takes quite a lot of time. Yeah. So we start from FPGA and we are right now working on ASIC. So it's a specialized chip for ZKP to achieve the real-time ZK proving goal. Yeah. So in addition to that, we are going to announce some software pack to wrap around the hardware very soon. So probably in 2 to 3 weeks. So stay tuned for our upcoming announcement. So our Twitter is CySig, CYSIC -XYZ, I think. Yeah.
Wonderful. I will definitely keep you on my scope. Thank you so much, Leo. Florian?
Yeah. So thanks for having me as well. If you want to get started with Mina, OpenJS and all that stuff, take a look at our docs. It's docs.minaprotocol.com. Play around with OpenJS, build a smart contract, a CK app, and stuff like that. Join the Mina Discord. There's a lot going on there. There's a very big developer community. There's all sorts of grant programs being run by the Mina Foundation. There's CK Ignite that just finished, and there's going to be another one, I'm pretty sure. There's other grant programs that you can get involved with, get funding for your projects, build out the application, get help and stuff like that. So can recommend that. Follow us on Twitter. That's O1 Labs. Look at our website. We are also hiring if you're looking for a job in the industry. And yeah, thank you for having me.
Our pleasure. Thank you. Alexander, please.
Yeah, we have a few resources for developers to look at. First of all, it's of course our documentation portal at devs.polygonid.com, and then we have Discord, we have a Telegram group. You can find them on our website, and we have a YouTube channel where we publish some interesting videos on architecture, on concepts of self-sovereign identity, and so on. So follow us there, and yeah, see you on future hackathons.
That sounds good. Thank you, Alexander.
Thanks for having me.
And Joanna, please. Aleo has been quite for a round a while, and please tell our community how they can get involved with you.
Absolutely. Yeah. So to get involved, basically first just to understand which category this person is part of. So we have a prover community, which working hard on these ZK proving. Like we have a proof of work consensus mechanism as well as a POS. Is a very unique design. So on the proving side, we work really hard on the accelerating hardware innovation. We work we talked to both Sisek and Ingo Niyama on Z-Prize. So something that I wanted just to touch on. Sorry, Emmanuel. You should submit this client-side proving idea as a track, right, for the next Z-Prize that we host. But to get more involved there, just go to zprize.io. That's the website that's going to continue to provide information on that. And then if you're a validator, we can. It's an open source protocol, so we can talk about how to get you set up on the node. And then as a developer, you can also get involved with the ambassador program, which I think we're always looking for people in local regions to host these meetups and technical workshops. And we're going to announce another round of testnet incentive program. So stay tuned for that. We also have an ongoing grants program that you can go check out on aleo.org/grants with S at the end. And also, Twitter and GitHub, just go search for Aleo HQ. And thank you again for having me as well.
Our pleasure. Nilufer, please.
Yeah, we have a very exciting news. At Gavolot, our DevNet will launch this month on the 5th of March. Yes, and it will be open to everyone who wants to join. Either a user who wants to who has need of generating a proof, or provers can join. In order to join, you need to register keys, and you can find more information on how to sign up and register at our website, gavolot.com. Also, in April, we will join ZK Summit and ZK Accelerate events in Athens. And for our socials, you can follow our latest updates on Twitter, and feel free to join our Telegram group and reach out to us. Thank you.
Well, you heard it, folks. Our pleasure. Also to you all, it's, a few words can only describe the pleasure to have you on today. So thank you so much. It was very insightful. I believe our audience loved it. And you heard it, folks. Keep an eye out on all these builders. And I'm looking forward to cross paths again. Thank you so much, everybody.
Thank you.
Yes, so we came to a close of the Zero-Knowledge DemoDay event. We had 8 showcases and we had 8 panel speakers at a captivating panel discussion. I don't want to only thank the startups, the panel speakers, and absolutely the judges and media partners, but most of all also the audience that has been with us. We at Pitch Talk are a premier platform that incentivizes founders to fully showcase their potential and vision in front of a captivating audience like you. So appreciate you all and looking forward to have you on board again. A little bit of alpha. Next month, we have the second RWA Demo Day, all about tokenization with some world names on board. So I will definitely recommend you check out our website, our platform, pitchtalk.com, and hopefully see you again. Thank you so much for being with us and have a great evening.